Okay, this is question 12, which is a three-parter from an introduction to statistical learning. This question is fairly short, and so I'm going to be doing both R and Python in one video here. Okay, we will march through the three parts here. So the first part asks us to recognize again that the beta coefficient is given by this expression right here, right? And it wants to know under what circumstances, so actually let me back up. So the beta coefficient for the regression of y onto x, right? So when we're regressing an outcome variable y onto a predictor variable x without an intercept, then the beta coefficient, or the estimate of the beta coefficient, is given here. Okay? And the first thing we need to know is when is this beta coefficient the same as when we regress x as now the outcome onto the variable y, the predictor variable. Okay, here's that question. So the regression coefficient for y onto x being this, and the opposite when we regress x onto y, which is now this, okay, are equal when the denominator terms, the sum of the x squareds and the sum of the y squareds equal one another, right? And so this should make sense. So when we go through here, if I look at this beta coefficient versus this beta coefficient, the numerators are always the same as long as we're working with the same data, right? Because x multiplied by y is always the same as y multiplied by x, okay? And the sum of those two things is always the same. And so the thing that differs here is just the denominator, right? So when the denominators are equal, then the beta coefficients should be equal. Okay. So in parts B and C, we're going to kind of demonstrate this to ourselves. So in the first one, we want to set up some data, x and y, where the regression coefficients, or the beta coefficients, are different when we regress y onto x versus x onto y. Okay, and so this is really just, in order to do this, we need to generate data where the sum of the x squareds is not equal to the sum of the y squareds. Okay, and so that's easy enough. So here I've generated some x variables. Okay, a random variable, a random normally distributed variable with a mean 0, and then y, a random normal distribution with mean 10. Okay, and now I'm regressing both of these, y onto x and x onto y, without an intercept. And the way you do without an intercept is with that by putting a 0 in there. Okay, and then I will, I guess I've already done it here, but I will show the coefficients for these two models. Okay, and so when we regress y onto x, the beta coefficient for x is this, and when we regress x onto y, the beta coefficient for y is this, right? And they're not equal. Let's just move on to part C here, and then I'll jump to the Python. So now we want to generate an example where the beta coefficients do equal one another. And so what we need to do is we need to find a way to set the denominators equal to one another, which means setting the sum of the x squareds and the sum of the y squareds equal to one another. Okay. There's probably a lot of ways to do this, but to me the simplest thing to do is to just make y the negative of x. Okay, and for so that's what I'm going to do. So here's my x variable again, and now my y variable, I am sampling, taking a sample from x. So I'm going to pick a value from x. Okay, I'm going to do that 100 times, and by putting replace false, it means I'm going to get each value of x once, okay, but just in a different order than x. That's important here because if you don't do that, then the model, there's no noise, there's no variance in the model to be estimated. But anyway, I'm taking whatever value I pulled from x and I'm making it negative. Okay? And so now again, I have my two models. Okay? No intercept. Well, I guess I already ran it. And now we have identical estimates for the beta coefficients. Okay, so now we've demonstrated what we showed in part A. Okay, quickly jumping over to Python. So, so we've already gone through part A. Here is the code to demonstrate this to ourselves in Python. So I need to import the packages seen here. Okay. Again, I'm generating a random variable x and a random variable y, and they have different means. Okay. And because they're going to have different means, the sum of the x squared and the sum of the y squareds are going to be different. I run my two models, y onto x, okay? And then I'm going to show the parameters here. Notice that we don't need to specify that there's no intercept, right? So R assumes that you're using an intercept, and so you have to tell it that you're not by adding a 0 into the formula. And here in Python, it does the opposite. You have to tell it that you're using an intercept. It assumes no intercept, okay? So when we run this, this is the beta coefficient for y onto x, and this is the beta coefficient for x onto y, okay? And what's important here is not the specific values, it's that they're different, okay? So when you run this, you'll get different random numbers that are going into the regressions, okay? And now for C, again, same thing as we saw with R. I have my x random variable, and I'm doing the same thing to generate the y variable. Okay, I'm randomly sampling from x. I get each value of x once, but just in a different order, and I make it negative, right? Because when I square the negative, then the sum of we get the same values. I go to print those parameters, and now they are identical. Okay, that's it. Thank you.